Hello everyone. Today I will be giving a video lecture on the metals and metallic minerals on today's Earth. So to start it off, I am going to give out a few facts about metals to give you guys a brief understanding before I get into the specified material. First off, the word metal derives from the Greek word metallon, which means to mine, excavate, or extract from the ground. There are all sorts of different types of metals. Some are pure and some aren't. The periodic table divides up the metal into different subcategories, including, but not limited to, alkali metals, alkaline earth metals, and transition metals. Many metals we use today are what you call alloys. Alloys are metals that combine two or more elements. They can also be called metallic compounds. These are often stronger and harder than pure metal. Steel and aluminum are examples. Okay, so beyond the fact that metals and elements are on the periodic table, what exactly are metals and metallic minerals? Metals are usually solid elements at room temperature except for mercury, and have distinct properties associated with them. Metals are good conductors of electricity and heat for the most part. Also, a lot of metals are either heavy dense or lightweight, some so light they are even able to float on water. Most metals are hard, however can be malleable. This malleability allows the metal to be broken down into a thin sheet. In addition to that, a lot of metals are ductile, which means they can be deformed into a wire shape without losing their strength. To the bottom right, you'll see a picture depicting metals beat down to thin sheets as a finished product. A cool fact about metals is that they are sonorous as well, which means that they can create a bell sound when struck. Due to the fact they are so strong, metals tend not to break, but bend instead. You're going to see metals be extracted with other elements, which can have different uses depending on the element used to combine. Some elements that can be combined with metals to create these minerals are oxygen, sulfur, and carbon. Lastly, if you want to have pure metal elements, you're going to have to extract the metal from the unwanted rock. This can take a while depending on your equipment and the type of metal being extracted. The picture to the top right of this slide shows an extravagant metal mining facility used to extract valuable ores from the Earth's crust. So next we're going to talk about abundant metals. Abundant metals are a subcategory that focuses on the more common metals found on the Earth. These metals are the type of metals you will see in your everyday life. They are crafted into almost everything because of their availability and their strength. These metals are also known to be bonded with their silicate material very tightly, so they need special extraction equipment. Some examples of these abundant metals are iron, aluminum, magnesium, titanium, and manganese. We'll first start off with iron. Everyone for sure has heard of iron. Iron is actually the most common metal found in the Earth. It is seen as ductile, silver gray, soft metal, yet still very strong. Over 95% of all metal usage today consists of iron. About 50 million metric tons of iron is used every year, which shows how valuable iron is to our society. Some notable things made of iron are your daily cutlery and some parts that can make your car run. Next, we have aluminum. Aluminum is a very light metal that we also use in our everyday lives, as you can see by the picture of the aluminum foil on the left. Aluminum accounts for 60 million metric tons and is the most abundant metal on the surface of the Earth. So to clarify, the Earth's most abundant metal overall is iron. However, aluminum has the most if we count the metal found in the crust. Magnesium is a little bit less common and known as the 8th most abundant metal in the Earth's crust. It's a strong metal with a silvery white color to it, and it has about 2/3 of the density of aluminum, thus making it strong and lightweight. Magnesium is the third most often used metal behind iron and aluminum. It is mainly used to combine with aluminum to form a stronger alloy. Titanium, as you may know, is very, very strong. So strong, in fact, it is used in extremely important structures. The background for this PowerPoint is of the ISS, or International Space Station, and guess what? Many of the parts on the space station is made of titanium. The Boeing 737 is another notable piece made from this strong metal. Not only is it strong, it's lightweight, as it's only 45% the weight of steel. This is most likely the reason why it is used in aircraft as often as it is. The last example of abundant metals I have is manganese. This metal is mainly used for the production of steel, accounting for 90% of the manganese mined today. Manganese is also used to alloy with aluminum to help resist corrosion. Manganese is the fifth most abundant mineral in the Earth's crust and is very reactive to other elements. So on this slide you will see examples of abundant metals in their pre-mined state. Figure A is iron, Figure B is aluminum, Figure C is magnesium, Figure D is titanium, and lastly, Figure E is manganese. These are just some of the more common abundant metals on the planet. Now that we've covered the most common metals and metallic minerals on Earth, it would only make sense to talk about the scarce metals that cover the Earth as well. Scarce metals, as you already know, are the rarest naturally occurring metals and metallic minerals on the planet. These are still highly malleable and usually high in luster. Scarce metals are mainly used not for the building and combining with other elements, but used in exchange as commodities or investments. If it's not obvious already, these scarce metals drive a higher demand and price than the abundant metals. Already known as the precious metals, these elements have some industrial uses but are most known for their jewelry and coinage properties. A couple of examples of scarce metals, also known as coinage metals, are gold and silver. Gold will be the first one I talk about. So generally gold is just as shiny and malleable as any other metal. However, there are several facts that make it one of the most prized commodities. It is measured in carats, and 24 carats is equal to 99.99% pure gold. Gold bars that are this pure used to be kept in high security vaults like Fort Knox. Some interesting facts about this expensive metal are 2/3 of the world's gold is mined in South Africa. 78% of the world's year supply of gold is used in jewelry, as that is its main use. The rest of the gold goes to electronics, dental, and medical uses. The next highly in demand metal I'm going to talk about is silver. Of all the metals, silver is the best conductor of heat and electricity, and the best reflector of natural light. This makes it a good material for mirrors. However, silver needs periodic polishing to prevent tarnishing. Pure silver is too soft for jewelry, so most of the known silver products are actually alloys combining silver and bronze. Today, the most silver comes from places like Mexico, Peru, and China. This slide shows what some scarce metals look like before they are refined. Starting with figure 6A, which shows copper, a great conductor, B shows zinc, an essential trace element, C shows platinum, an important element for car parts, D shows chromium, which is used today for things you want to be really shiny, E shows gold, which is a precious commodity and one of the most valuable elements monetarily, and F shows silver, which is another valuable commodity but also a great conductor. In summary, we have talked about two subcategories of metals and metallic minerals in today's Earth. By now you should be able to differentiate at least the most known metals as abundant or scarce. However, if you haven't, here's a quick summary. To quickly reiterate, abundant metals and minerals are the most common metals and are mainly used for building and combining with other elements to create alloys and whatnot. Examples of these are iron, aluminum, and magnesium. Scarce metals are way more rare and more difficult to extract. Also, their value goes way up when they're at their purest state, especially since they are used as currency and investments at times. So hopefully by now you've learned something about abundant metals and scarce metals. I know for a fact I didn't know much about the difference between the two subcategories before I started researching. Before this, I thought metals and metallic minerals were pretty basic and a bland topic. But honestly, I've learned a lot regarding this topic, and I just hope I could teach it well enough so that you learned something too. Thanks for watching.